All right. So on Tuesday, we started talking about evolutionary theory and some of the contributors to evolutionary theory. Today is our Darwin Day. We're going to focus on Charles Darwin. Now, a reminder, I think I might have mentioned this to you on Tuesday, that we talked about Lamarck. He was the last person we talked about. And Lamarck, in 1809, made his proclamations. That was the same year that Darwin was born. And so Lamarck said, yes, organisms do evolve, but they're evolving towards perfection and complexity. Sounds like a bunch of hooey to me. That's weird. Perfection, what does he mean? And then we had our inheritance of acquired characteristics. Which we decided is not true, but it's kind of a fun theory to talk about. So today we're going to start with Darwin. And I want to start with a little bit of history about Darwin, about who he was. So Darwin obviously was born in 1809 in England. And he was the fifth of 6 children. So his early education was not a formal education. He was educated by his older sister. In this time, that was kind of unheard of a girl teaching a boy. But that was his early education. Until his mom died. And his mom died when he was 8. And after she died, his dad sent him off to boarding school. Now, Darwin's one of those scientists that we talk about who was an innovative thinker, but a horrible student. So Charles Darwin would skip school all the time. So he's off at boarding school, and he is not going to class. Instead, he's out observing nature, drawing pictures of birds and chasing little critters around to see what they eat and how they live. Now, I don't know about your parents, but my guess is if your parents called me and said, "Oh, how's my daughter doing in your class?" And I said, "No, she's never in class. I see her out in the courtyard drawing birds all the time." Would they be very happy? Probably not. They're paying tuition, good tuition, for you to be here in my class, presumably learning something from me. And so that was kind of Darwin's dad's idea, too, of if you're not going to go to class, why am I spending this money to put you through boarding school? And so his dad pulled him out of school when he was 16. Now, in his dad's mind, there were only 2 honorable professions for a man. One of those is to become a doctor. His dad was a doctor, his grandfather was a doctor, and when you do your reading, you'll learn a little bit about his grandfather. There's a little blurb about his grandfather. So that was one of the honorable professions, becoming a doctor. The other is to become a clergyman. So we're in England, we're talking about the Anglican Church. They don't have priests, but a clergyman would be the equivalent of a Catholic priest. One big difference that's going to be influential is that Anglican clergymen can get married. So that's going to make an impression later on. So at 16, his dad tells him, okay, one of these 2. You've got to do one of these 2. And so his dad sends him to medical school. Obviously a very different time. I would not trust sending one of our current sophomores to medical school. Nothing personal against them. I just don't think you're really ready at 16. He had some problems with medical school. His biggest problem was he was afraid of blood. That could be a stumbling block. And then his other problem had to do with the times, really. So at this time, we didn't have good anesthesia to knock you out when we were doing surgery on you. We might be able to get you a little loopy with some ether, or maybe get you drunk. You won't feel as much then, but drinking alcohol thins your blood, so you're going to bleed more in the surgery. So he didn't really like that whole idea of cutting people open while they were aware that they were being cut open. Can't say that I blame him much there. That doesn't sound like such a good time to me either. And so after about 2 years of medical school, he drops out of medical school. So he's exhausted one of his options. So the other option is to become a clergyman. So in 1828, he entered the University of Cambridge. To become a clergyman.
Where did he go?
University of Cambridge. Around this time, he met a girl. She's going to be important. Her name is Fanny. That's not important. And in 1831 is one of the dates. There are 2 dates that you'll need to know, and that's one of the dates that you really need to know. In 1831, he graduated.
1831 is the day we have to know?
Yes, that's one of the dates you need to know. So he graduated. Yay. Kind of downhill from there, though, as far as this year. This was a big year for him. So he graduated, and Fanny dumped him. Yeah, so they'd been together for 3 years, and then she dumped him. But to make matters worse, on her side of things anyway, about 4 months later, she married one of his friends. Something sketchy's going on there. They were together for 3 years. They break up, and 4 months later, she marries one of his friends. I don't know about you guys, but I find that a little sketchy.
Wait, 4 months?
4 months later.
Oh.
Yeah. So he is devastated. Cora?
I was gonna ask, so was Darwin still friends with his friend?
That I do not know, but I would doubt it.
Okay.
So he is devastated by this. And another friend of his says, let's go on a cruise. Let's get out of England, get you away from Fanny and her new hubby. Let's just go away, go on vacation, get away. So that sounds like a good idea. Shortly before they were getting ready to go on this cruise, his friend dies. Like I said, 1831 was not a good year. It was an eventful year, but not a great year, aside from graduating. Leah?
Did he die of like natural causes or like what happened?
You know, people have asked me about that, and I've never been able to figure out the circumstances of his death.
Wait, the one who wanted to take him on a cruise died?
Yes. Oh. My guess is it wasn't natural causes. That would be my guess, but I don't know. So we're still in 1831. God bless you. And another friend of his, he's trying to worry about his friends here. Another friend of his suggests that he apply for a position on the HMS Beagle. So HMS stands for Her Majesty's ship or His Majesty's ship, depending on who's in power at the time. In this case, it was Her Majesty's ship, the Beagle. And what this position entails, it's a two-pronged position. The big prong is that he would be a naturalist aboard this ship. And basically what that means is as they sail around the world and go from port to port, that he observes nature. Sounds like a perfect job for him. He's been doing that since he was a kid when he wasn't supposed to be doing that. So it sounds like a good job for him. The second prong of the job was to be a companion for the captain of the ship. So have meals with him, have conversations with him, I don't know, play chess with him, kind of be his friend. So he applies for this position and he gets it. And so in December of 1831, the HMS Beagle set sail. On a 5-year voyage. As I said, they sailed around the world and they returned to London then in 1836.
Do you have to know the exact date?
1831 is the important date to know, and if you know it's a 5-year journey, then you're fine. Evelyn.
So his job was to be a nationalist and to be a keeper?
Yes.
I didn't know.
Nope, it was for both. The job was for both. Yeah, because if you think about it, when they're out at sea, there's not really anything to observe that much. And over 5 years, they spent a lot of time at sea. All right. So it's during this time on the Beagle that he makes his observations that he will tie into evolutionary theory. Cora?
Observations that tie into what?
That he will tie into evolutionary theory. Leah, did you have a question?
Yeah, on the 5-year journey, did they have to stop?
Yes, and there's a map in your textbook, I believe, that shows where they went and where the places where they stopped. So when he gets back to England, he's kind of reluctant to pour all these thoughts out. He does publish little papers, but he's not sure how the church is going to react to his theories. He's not sure how just the general public's going to react to his theories. And so it isn't until 1859, that's another date to know, so 1831 and 1859 are the big ones. It isn't until 1859 that he publishes his work, The Origin of Species. 650 pages detailing his observations and how they tie into evolutionary theory. The Origin of Species. So we're going to kind of condense this down a little bit and get to the heart of it. Like I said, there's a lot of examples in here, though, because he's trying to show the evidence that he found on his journey. And so that will lead us to his theory of evolution. Now, just to kind of tie up Darwin as far as the person, I will let you know this. He did eventually marry. About 3 years after he got back to England, he married his first cousin. Yeah. When we watch the crash course on evolution, when he does his biography, it's about Charles Darwin, and he talks about how inbred that family was, with people marrying cousins, and yeah.
Did he have kids?
They had 10 children together. 3 of them did not survive to adulthood. They died during childhood, which is not surprising given their inbred nature. So, yeah. So, in your textbook, and you'll see this in your assignment, in your textbook, they list 4 pieces of Darwin's theory of evolution. I'm going to talk about a couple of them, and then I'm going to try and glue them all together for you. So one of Darwin's observations was that organisms produce more offspring than the resources can support. So by resources, we're talking about food and space and mates, that kind of thing, the things that you need to survive and reproduce, that kind of thing. And so if we're producing too many offspring for the resources, that means that there's going to be competition for those resources. Another thing he noticed is that there is variation within individuals. So both of these cause differences in reproductive success. Both of these cause differences in reproductive success.
When you say both, you're talking about that organisms produce more offspring and that there's more variation.
Yes. So remember, sorry, Evelyn.
Causes differences in what?
Reproductive success. So we said on Tuesday that really the key point of his theory of evolution is that evolution is driven by natural selection. So let's kind of pull this all together then into what natural selection means. Organisms that have traits that allow them to get resources are more likely to survive to reproduce, survive to reproduce, reproduce. And will carry those traits onto their offspring.
So like would an example be like giraffes?
Yes. Okay. So giraffes would be an excellent example. So if a giraffe has a long neck already, then he can reach the leaves. He can get to the higher leaves. And so he's getting the resources, he's getting the food. So he's more likely to survive and reproduce, and then the genes for the long neck will be passed on to their offspring. Cora.
So then, if like an organism, like say giraffe, like a really long neck, and that allows him like to get the leaves and stuff.
Mm-hmm.
So like, do they know to like mate with another giraffe with like a longer neck, or?
Yes, in a way. I mean, that's part of mate selection, which we'll talk about. I think we'll talk about it on Friday. I think on Mondays when we're going to be talking about mate selection, but we'll be talking about those kind of things. It's like with cardinals. Okay, we'll use that as an example. Perfect day for it since we're all read it out today. With cardinals, female cardinals are kind of brown in color. Okay, the males are the pretty red ones. Well, the females, they get to choose their mate. The males don't get to choose. The females choose the reddest cardinals because that means he's a healthy cardinal and he's going to be a better provider. And then her offspring will be those healthier, redder cardinals. So one of my favorite examples of this is not an authentic one, but it's a fun example. So how many of you wear contacts or glasses? So about half of our class, roughly. Okay. And so the idea is, okay, so as humans, it's really hard to deal with humans and evolution because we do lots of things to make ourselves fitter. Okay, we do external things. We've got our technologies that help us to be more fit and more able to survive in our environment and get resources and survive. Yeah. So think back to, so we have these glasses and contacts that help us to survive. They help us to see where the heck we're going. And so we don't do silly things that we might do if we could not see where we were going. So like, for instance, with my glasses, I know if I take off my glasses, you no longer have faces. And the further away from me, the less features you have. I mean, even up close, you don't have faces. But back there, oh, you guys just blend into the bookshelf. Yeah, if you don't move, I'm not going to know you're there. Okay, exactly. Okay, so if you think back to a time before we had these glasses and contacts, so we think back to, I'm going to go back to caveman times, if you will, okay? And so my eyes are bad, and I'm walking around, and I see something over there, and I'm like, ooh, puppy, I'm going to go pet the puppy, and I go and I pet it, and it's a lion, and it eats me, and I'm dead, okay? So I'm no longer able to carry on my genes then to the next generation. And if that happens before I reach puberty, I'm not able to reproduce anyway yet, and it probably would have happened by then, knowing myself, because I got glasses before puberty. I was 10 when I got my glasses, and so yeah, okay. So there have been, when I was 10, I probably would have done something like that. You know what I mean? I see things like that now, and I want to go pet them, but I know better because I can see what they are and know that's not petable. Okay. So I would not carry on those genes for bad eyes then onto the next generation. That would have been wiped out. The people with good eyes would have seen that it was a lion and gone the other direction.
This is kind of random, but then like what? Why do you have glasses? Just because? Like I don't know, because some people are farsighted and some people are like nearsighted.
And well, technically I'm nearsighted, but I've come to the point where I actually have bifocals now. I can't see up close and I can't see far away. There's like one point, like right here, I can see perfectly, and otherwise I can't do it. So, but the reason why that's not a great example is because not all of our eye problems are hereditary. Okay? So, like I said, about half of us in here have some kind of eye problem. And so a lot of that has to do with technology, artificial lights, being on computers a lot, that kind of thing. Right? So those are environmental stressors. It's not a genetic stressor. All right. So with natural selection, nature is deciding what are the good traits. What are the traits that will help you survive? Darwin also talked about artificial selection. And with artificial selection, it's the humans who choose which traits are favorable.
So for natural selection, it's like through genetics.
Right. Well, it's all going to be through genetics because you get your traits through genetics. But with natural selection, it's nature that's deciding. Okay. So, like with the giraffes, it was because the leaves were high in the trees that the longest giraffes could get to them. Okay. With artificial selection, it's us who's choosing. So, the best example of artificial selection that always comes to mind is like with breeding dogs. So you're breeding for particular traits that you find desirable in that dog. So for instance, my brother has a standard poodle, and they say her official color is brown, but she's kind of that like buff kind of color. And so she was bred to be a gentle dog and to be that buff color. So, okay, that's what we want in our puppies. And so they found a male and a female that were buff, gentle, standard poodles, mated them, and voila, here's my brother's dog. And then once she was born and started to develop, and it's found out, yes, she is gentle. She's got the right coloring. The breeders wanted to breed her with a male who would be also that same color and gentle for more gentle, buff puppies. I discouraged my brother from doing that. But anyway, that's the whole other story. So that works. Okay. We do it with chickens to get nice, plump chicken breasts. So they have lots of breast meat. They have lots of muscle in their breasts. We breed the plump ones with the nice plump breasts, and then we get the nice juicy chicken breasts from our grocery store. It's the same thing. Now the problem is with artificial selection is that when you're just focusing on a couple of traits, you're leaving all the other ones behind. And so we kind of get that same idea of inbreeding. So because we're breeding for just a couple of traits or just for one trait, the other traits then kind of get mingled and you get that kind of inbreeding thing. So like with my brother's dog, yes, she's a beautiful buff color. She's very gentle, dumb as a stick. Okay, so the intelligence went away, but he got what he wanted in her. Okay, Cora. Oh, here's Kate.
So you can read like dogs, like how a dog acts, because it's like their personality kind of.
That's the theory, yes.
But you can't do that in like just like if your parent was mean, does it mean
Well, and so much of it, and especially with humans, but yes, especially with humans, has to do with your environment. So that's kind of what determines your temperament.
Is that why like a lot of mixed breeds have like really bad like joints or something?
Yes. Yes. Yep.
Don't mixed breeds have like better? I don't know.
They usually have a little bit better fitness.
Yeah.
Overall, yes, they do. Like with my dog, he's a wolfhound, and took him to the vet a couple weeks ago because he was just whimpering, just walking around the house whimpering. Took him to the vet, and the vet said he's expired. His life expectancy is 8 years, and he's 10. And so the vet's like, he's just old. He's past his expiration date. I'm like, don't say that. Then the next day he was fine, and he's been acting normal ever since. So. Big dogs usually have a shorter life expectancy. All right, so Darwin obviously, in that 650-page book, he obviously made lots of observations. Okay? And so we have evidence for evolution. It's not just something he pulled out of thin air while he was rocking around on this boat for 5 years. Okay? So some evidence we have for evolution, the fossil record. We look back through the fossils and see organisms that are not exactly like the presently living organisms, but they're similar. And then we go back a little bit further and they're a little bit more different. And then a little bit more different. There is a great diagram in your textbook that shows whales and their relatives going back in time to a time when they walked on land. And the way that the bones rearranged over time to allow them gradually to be whales. Whales. That's a good question. Probably not.
What were their legs?
Probably.
Their legs must be so strong.
Well, yeah, the musculature would be different.
It's like, what?
You'll see when you do your homework. All right, homologous structures.
Very stupid question, but maybe humans shape differently, like back in the day. Because if whales can walk, what can humans do?
You're not. No, not that dramatically.
Sorry, what was the definition?
Just looking back at the fossils over the years. All right, homologous structures. Homologous structures are structures that are similar in different organisms and may or may not have the same function. Now this kind of overlaps with the next one that we're going to talk about. So when we're looking at homologous structures, we're looking at like what kind of tissues did they arise from, and if they arose from the same tissues. So for example, taking a look at limbs. Okay. So all of the things in yellow are homologous, all of the things in the lighter brown are homologous, of the darker browns are homologous, the white's homologous. So here, human hand, okay, so these little browns here, these are the carpals, and this is the ulna, okay, that runs along your pinky. Okay. The ugly ulna, yes. Okay. So if we go over to here are the carpals, but this little bone right up here at the top, that one is what's left of their ulna. Cat doesn't look too different. Okay. So you can see the similarities and the differences. Now, as far as function, okay, we start over here with the whale. Okay, he's going to use that to swim. Okay, the bird doesn't really use his too much to fly, but it's part of his wing. And then the bat to fly, and of course we know it. Yeah.
That's a bat's wing?
Yeah.
That was its hand.
Bats don't have hands.
I thought it was like we could have little hands on the end. Like there's two fingers. Like,
Look at him.
where is two little fingers? Terrifying.
Oh my gosh.
Okay, but is that a whale's like fin?
Yes.
Okay.
No, whale's hands like a
All right. Embryology. We're almost done.
Is this the last thing?
No, there's one more after this. Embryology is studying embryos. And when we look at very young embryos, they look very similar to one another. So what this is suggesting with the homologous structures, and we'll see with the embryos too, that there's a common ancestor or a similar ancestor. That's the evidence we're looking for. Leah first.
So you mean like the young embryos like that look similar to each other? Do you mean like through generations or like all in one like?
Take a look at this diagram up here, okay? So we're looking at the very top are young embryos of these 8 different organisms.
Oh, I see. Yeah.
So they, looking at the different organisms, they all look similar.
That's little shrimps.
Kind of.
The second one's good.
Oh, Sandra, did you get it?
I got it.
What animals are
Okay, so this one on the far right is a human, rabbit, cat, hog, a chick, tortoise, salamander, and a fish.
What's the green one?
Tortoise.
Don't you see the shell?
We all
Okay, close enough. What did you say the evidence?
The what was? I'm sorry.
Evidence.
We're looking for evidence of a similar ancestor or a common ancestor.
We look like all the same.
Exactly, that's exactly it. So that is, they look very similar up there, and then as they start to differentiate more, they start to look a little bit different, but still, the human and the rabbit look pretty similar, and the pig, he's just a different color, but his makeup looks pretty similar also. So this is evidence that there could be a common ancestor or a similar ancestor. Our last piece of evidence is DNA. All right, so looking at the sequences of DNA. So here, what we're looking at a single protein that's found in all these organisms. This protein is hemoglobin. It's the protein that's in your red blood cells that carries oxygen. And what are proteins made up of? Amino acids. Okay? And so what we're doing is we're looking at the number of amino acids that differ in comparison to humans. So if we look up here, the rhesus monkey has about 10 different amino acids in this one protein than a human. Okay. Whereas if we go all the way over here to the lamprey, the jawless fish, his hemoglobin, that single protein, has 125 different amino acids than a human. So what this suggests to us is we are more closely related to a rhesus monkey than we are to a jawless fish. Because we're comparing it to the human. So we have 0 differences in ours. So it's all relative to the human. Claire?
If you had the mutation, would you be like more like a monkey?
You would have to have a pretty severe mutation. Pretty severe mutation. Because this is just a single protein. Okay? So that would be a really severe mutation. All right, so on that note, do you want to say bye?
Bye!